So we are expecting आज कम बच्चे इधर यहाँ पे चलो बैठो you are a new admission this is your first lecture for physics yes it's right okay stay there okay where were we last lecture you were not available right you didn't attend so what we do madam told me that I have to teach your portion what does it mean what we doing numericals or
two chapters of thrust and pressure and heat transfer.
So pressure is first. Did we start pressure?
Yes, we start with pressure.
So shall I complete pressure first?
Yes.
So till where we have covered pressure? Check your notes. Till where we have completed? Pressure किया ना? Pressure कहाँ तक किया ना?
So जब तक so we have started and we have until what pressure depends on. We have derived the formula in liquid pressure.
No, but I think we have started with numericals also. We derived the expression for. You were also absent in the last class.
The last class was already.
Acha, so then you won't have advantage here. Same question. Last class was what? Technical or extra one? So we had derived the expression for due to liquid column. Pressure due to liquid column. Suppose you have a liquid column. So if this is the height, okay, and if this is the area, right? Then pressure is given as H rho G. Yeah, thrust upon area. The pressure is thrust upon area. Till here we have completed. Okay. So what is H? H is depth.
Height.
Depth
Of the water column.
of liquid column. Rho is density of liquid column. G is gravity at a base. That is what it is. Shall we switch it off completely? It's coming in mind. Which one is that one?
Last.
It's not last. Let's see if it works. This time if it goes, I will close it off. Okay. So then we have, total pressure is equal to, that also we discussed. Total pressure is, if there is some atmospheric pressure above the column, then total pressure will be equal to
atmospheric pressure plus
the pressure due to column. Okay, so this is the total pressure. Okay, next is what are the factors affecting pressure? These are the factors: depth, density, and gravity. These three things. Pressure depends on these. Then there are laws of liquid pressure that also we completed.
yes.
So then some consequences of liquid pressure. The first is, so read. This also we covered. Pressure at a certain depth in seawater is more than that at the same depth in river. No. So obviously, so depth is h, right? So at the same height, let us say at this height, if this was a river water, the pressure will be different. And if it was a sea water, the pressure will be different because sea water has higher density.
Because
Salt, minerals are there. So sea water has higher density. So when if H is same, right? Due to rise in or increase in density, the pressure in seawater will be more at the same time. Okay. So that is point number one. Second, you also follow cylinder, right? Okay, good. So wall of the dam is made thicker at the bottom. Why?
Because the pressure increases downwards. So
Yes. So there is maximum pressure here. So if the wall is thick, it might break at the bottom. So thicker wall is. So it will be able to, overcome or withstand more pressure. Large force will be there, it will be able to withstand. The water supply tank is placed high. Obviously, if the supply tank is high, so the height through the pipe reaching your tap, so there will be a higher column. High tap will increase the pressure in your tap. So that's why the tank is kept high. So to maintain suitable pressure at your tap. Then the diver suit. So sea divers, because for deep sea, at deep sea, seawater has one higher density, therefore with rising depth, the pressure will considerably increase. So the sea diver may not be able to breathe, right? So, and what is the pressure outside? Atmospheric pressure. Okay, so which is 180. Atmospheric pressure is equal to 1 atm, and this is equal to 1.013 into 10 raised to 5 Newton per meter square or Pascal. So we are accustomed to living at this pressure, atmospheric pressure. So deep sea diver has a specially designed suit of a different material, which is reinforced plastic. Okay, it is either reinforced plastic or cast aluminium. So it maintains the pressure inside the suit at 180. So the sea diver has ambient pressure environment around him because of the special suit. So then he is able to function normally. But still, how deep can he go?
In the function and the suit functions.
Uh,
After certain limit, the suit might also experience pressure.
Obviously, not forever, right? So it's about 2,000 feet. Yeah, roughly 2,000 feet, 2,300 or something like that. So that's what is the last recorded, I think. You can check on the net normally. Then size of the gas bubble inside the water. Okay. So it is noticed that when the bubble comes out, okay, as the bubble rises up, its size increases. Gas bubble size increases. And once it reaches the surface, it pops out. Okay. So why the size of the bubble increases as it rises up? Now see, so where is the pressure more? Down. So here it experiences high pressure, right? So as it goes up, the pressure keeps on reducing. So there is this Boyle's law, right? Volume is inversely proportional to pressure. This is the Boyle's law. So volume of the gas is inversely proportional to pressure. So if the pressure reduces, the volume increases. That's what happens. So what is it? The gas bubble formed at the bottom of the lake rises. Okay, it grows in size. And this is the reason.
So, but how are bubbles formed? Just because of the trapping of the gases.
Any gas, no, like if any gas is released or any fish is respirating,
So
etc.
does the volume mass remains the same, only the volume increases.
Yeah, the air molecules are spreading out, expanding. Okay, understood. Next is transmission of pressure in liquids. So this is basically what is called as Pascal's law. So in this case, let us say you have a round bottom flask, right? And this is the initial level till where the liquid was filled. And imagine you had a piston here. Okay. So this is a confined liquid. Is this flowing liquid? No. This is a confined liquid, right? Now what this law says is, now suppose a thrust is applied here. Okay. So then it has area. So thrust upon area of the piston. This is a piston, right? This is a piston. You understand what is a piston? Like a pump. So you have put pump. So you have a piston. When you pump it, it will push the air. Okay. So, but air is fluid. In this case, the fluid is liquid. So it will push the liquid. Now what has happened is, let's take out pipes from various levels. So let us say we have pipes from so in this pipe also the water level will be same, right? Whatever was filled initially. This is basically to demonstrate the whatever is the pressure exerted, okay, so these all pipes are of uniform cross-sectional area, and initially the water level or liquid level field was
Uniform cross-section area means that it's
same
5
thickness,
meters wide.
same thickness of each pipe. Even if it is not same thickness, it does not matter. Because the shape of the vessel is irrelevant. Okay. Now what is being done is, so till here the water is filled because liquid finds its own level, right? When you press it down, so let us say the piston comes here. This is the new position of the piston, right? So what we experience is, we get a fountain, water fountain coming out of each. And the fountain height is same. Yeah, same fountain height is observed. So what does this mean?
Pressure exerted is same.
So everywhere the pressure should be same. Same pressure is exerted here, 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 and here. And what was the only pressure exerted? The only pressure exerted was P here. Okay? So irrespective of wherever is the point, at all point, the same pressure is transferred. Got it?
Yes.
So, because it is only the additional pressure which is responsible for this fountain. And since the fountain height is same pressure is transmitted at all points. Is that clear? So that is worded as Pascal's law. So you can read what is Pascal's law. It states that the pressure exerted anywhere in a confined liquid is transmitted equally and undiminished in all directions throughout the liquid. So you see, this is in this direction here. So the same pressure, whatever is applied here is passed over here. Okay. Of course, this is at a lower pressure than this, than this, than this. Okay. That is, but out here the level was same. Okay. So here, whatever additional pressure was applied, that pressure only must have reached here. And only that pressure must have reached here also. So everywhere same pressure reached. That's also.
So if the height is different of the tube columns, then
With the height, then how will you have the reference? If the height is different, the liquid will anyway will keep spilling there. In all the pipe, it will be maintaining the same height. Yes, got it.
so what if the height is different and we have measured that 5 centimeters is going up the water fountain? The height we do it differently. If it is
Which
not-
height is it? Anyway, heights are different only, no?
No, if the level is not same.
Of the fountain, it will never happen,
No,
no?
no, of the tubes.
So the fountain height is same, right? So let's say this was here.
Yeah, yeah.
That does not matter.
That means should be
The
5 centimeters.
outside level matters, outside level. So both are reaching at the same height. This tube height, even if it is lower, that is immaterial, no? The inside water level is same initially. So the height till where it throws, so that has the baseline is this one. So उससे कुछ फर्क नहीं। ठीक है? So now this is the basis of hydraulic machine. The hydraulic machine is operated by transmitting pressure through a liquid. Okay? So now let us see. So principle of hydraulic machine. What is a hydraulic machine?
So I think hydraulic machine is submitted. No, it's not possible.
So principle of hydraulic machine. Okay. So what is a hydraulic machine? So hydraulic machine consists of two cylinders of different cross sections. And it is both the cylinders are connected at the bottom to a connecting pipe. Now a liquid is filled in the vessels at the same time. Okay. Now these are cylindrical vessels, and now we have piston also. So piston basically provides airtight closing, okay, of the vessel. So now when you keep some weight here on this side, let's say you keep some weight. So this weight will apply some force, correct? Weight is nothing but force. And this piston has some area. Let's call this area as A1. So this is piston P1. From P1 to variable for pressure. Let's call this as piston C and Q. Okay. And this is area A1, this is area A2. These are cylinders P and Q, and in which you have piston, one piston of area A1, the other piston of area A2. So there is a thrust due to the weight. Thrust upon area will be pressure. So the pressure applied in the downward direction will be E1 here, right? So this is a confined liquid. So the same pressure will travel here, correct? At every point in the liquid, same pressure travels. So we are calling this pressure over here as P2. Because this pressure is now exerted on the second piston. And it has area and it has pressure. So this will result into thrust. So the second piston will experience thrust due to the pressure transmission. Okay. So how much will be that thrust? Zero. Now by Pascal's law, P1 must be equal to P2. Correct? What is P1?
Because the pressure is
Equally transmitted. Okay. So this must be equal to F2 by A2. So this will give you how much? F2 is equal to A2 by A1. This is what you get.
Right.
A2 by A1. Sorry. F2 is equal to A2 by A1. Okay. But A2 is greater than A1.
Yeah.
Correct? But A2 is greater than A1. This means A2 upon A1 will be greater than 1. So what do we get? Therefore, F2 upon F1 will be greater than 1. So this is the principle of hydraulic machine.
So if in F1 they are applying 5 Newton force, over it would be 10.
Yes, if area is twice of, so we can design the machine. So we get what do we get in hydraulic machine? We get force multiplication. Okay, so this is the principle of hydraulic machine. Now, what is the principle? So principle of hydraulic machine is force multiplication. By using Pascal's law. We use Pascal's law to achieve force multiplication. This is the principle of hydraulic machine.
So if, for example, over here F1 is having a body, right, towards a tail. If we are doing it manually, if we are applying force, is gravity involved?
Yes.
If we are applying force.
So force is mass into gravity only. Here it is muscular force. But here gravity is anyway helping us push this piston down, right? Piston also has its own weight, right? So gravity, atmospheric pressure, everything is helping.
So if we make it on a wall, will it work?
Like what?
Or it's
It will exert down the pressure of the wall. However, it is directed. You can design it. It is a confined liquid. So you can hold it anywhere, place it anywhere. Okay. This is the basic principle of the machine. The pressure is transmitted everywhere, undiminished. Okay, same pressure, whatever is applied over here, same pressure is transmitted. But it results into a larger thrust due to a bigger area. Same pressure acting on a bigger area results into a larger thrust. So now on the right side, we can build various applications. Let us say I fix a cabinet over here with a fixed mount. So anything I keep inside, it will crush it. So that is your hydraulic press. The examples of hydraulic press. The first example is hydraulic press. So it's working is very simple. So here now the machine is flipped like this. Okay. So the load is kept over here. F2 is overcoming the load. So what is the load? It is the cotton bale, okay, from the farms brought here, and there is a cabinet made over here by fixing. There's a fixed roof. So when the pressure is applied, how the pressure is applied? Now here is one handle connected, okay, through which a lever is attached, hand lever is attached, and there is a fulcrum, fixed point on one side, and the load is pressed, and the force is applied in the middle. So when you press the handle down, it will push it down. Okay.
So over here it's open.
So look here. So how it works is initially the handle is down. So there's no water. Okay. So this is the water reservoir or liquid reservoir. So when you pull it up, so this piston will
Creates a suction and then takes the.
So when you pull it up, so when you pull it up, so the piston will be pulled up. So it will suck water from the reservoir inside. Okay. And here you can see the valve. There is a lid. So when it is sucking water, when it is trying to suck water, atmospheric pressure will help us suck the water out. So this valve is open upward. Once the water is filled, now when water tries to go down, it will close down. So valve Valve is something which allows flow in only one direction. When water is coming up, it throws the valve open, it comes. Now when the water tries to fall back, it closes automatically through gravity action. Okay. So it's a mechanical valve which is closing on itself through gravity action. Now once the liquid is filled in, then what is happening? So look here. Then you have a connecting pipe to the other piston. Other piston also have a mechanical valve which works on gravity.
So, but why does the other thing keep on?
Here we are. So now when you press it, so this liquid will enter here. And this pressure is transmitted over here. Now this piston size is bigger, so more force will be acting here. Okay. Now when here also liquid flow is allowed only in one direction. So water cannot come out because then the valve closes on its own due to gravity. Okay. So once you press it, this plunger, piston plunger, will press the cotton cap here or anything. It could be mustard seed, linseed, etc. So coconut.
That will be pressed.
That will be pressed and oil will be produced. Here the cotton bale will be pressed into a thin sheet which can be rolled and packaged and exported. So anything you keep here will be pressed.
So,
Here you can do engraving on metal plate. If you want to engrave some logo or write something, so that can be kept here too.
so but
Then listen. Then you have a release valve. So once you've done the pressing, how do you use the machinery? So for that you release valve. When you release, all the liquid will flow back to reservoir. Okay. So now you have no liquid here. Piston is gone down. Both are down now. Both pistons are empty. So again you close the release valve and repeat the action. Then change the load if you want. Understood? This is how it works. Due to the change in the area, the machine acts as force multiplier. So a hydraulic machine acts as force multiplier. This is the principle of which it works. And it uses Pascal's law for pressure transmission. Okay? So this is one application of hydraulic machine. Why we call it hydraulic? Hydra is liquid. Also, that is the working substance. Every machine has some working substance. So here the working substance of the machine is water or liquid. Okay. For air, there are certain machines which use air.
and
That is called
air.
yes, that is called pneumatic machine. Pneumatics. Okay. So next is hydraulic jack. So this is also same principle. Now in this cabinet we have attached a platform. Okay, not a fixed roof. Now we have a platform, and that platform is big enough to hold a car or any heavy lifting if it is bigger weight. Then again you press a handle. So you are using your muscular effort. Any human is able to lift a car with the help of this. Because his force is multiplied number of times, which is equal to the ratio of the bigger area to smaller area. So you make this machine as thin as possible, this as thick as possible. Small effort you are applying, that is what resulting into bigger effort.
We can also make piston A much smaller. The vessel,
Yes, because shape does not matter.
right? Then
What matters is only depth, h.
depth or not
Depth to generate pressure. Right. So that is symmetrical. Okay. But here to generate, so force per unit area, thrust per unit area is required. So area matters.
If you make the,
So this is now acting as hydraulic jack or hydraulic lift.
make the area smaller, then much more pressure here, that will be.
Yes. The ratio, because it all depends on it. You make either this small, okay? So obviously you will make one small and one big. That's why you get a bigger ratio. Then you have hydraulic brake. See, in all our automobiles, car, etc., we use a brake fluid. Every automobile uses brake fluid. So when you press the pedal, there is one small cylinder there, that is the master cylinder. And then there is one more cylinder connected at the rim. So in the rim you have these rubber pads. This is called brake shoe. So they are, attached with the spring in them, and they are mounted here at the bottom. So there is a spring action which keeps the brake shoes near each other while the wheel is rolling. And if you want to stop it, then you press the brake. So that will generate pressure here. This pressure is transmitted, and here you have two pistons. This is a two piston cylinder. So when the brake is applied, it spreads out now. So then the brake shoe applies friction on the rim, and the tire is fitted on the rim. So it is on the inside, you can't see it from. You see it, it's like what you see the tire of the car, you see it from outside, you just look at here. You have the brake disc and all, you can see it. So it is not visible from outside, it's inside.
And what was the function of this brake?
So once you release the brake, the shoe has to come back home. It has to be, it has to contract again. It has to contract again so that the wheel can really roll again. Right? It's like otherwise you're pressing the accelerator and the brake simultaneously. That is not allowed. Only one leg is used for accelerator and brake. Have you seen it? You can see it. I mean, either you can use the leg to press the accelerator or the brake. You can't use both simultaneously.
What happens if you use
You cannot. If you use both, then you're trying, the engine is trying to pull the car and the brake is not letting it. So what's the point? Foolish effort. Okay. You understand? So this is what it is. Now look here. This is the Pascal's law of transmission of pressure. So you have three more wheels. You have three more wheels, right? So the same pressure is transmitted on all the wheels. So the braking is uniform. No wheel is getting extra pressure or less pressure. All of them are receiving same pressure. So that is the meaning. The same pressure is transmitted at all points in the confined liquid.
all the brakes?
So braking is very smooth. Imagine one wheel was experiencing more brake friction, other was less, then the car will skid. So this is called smooth braking. Right here. So this is it. And then you have this mechanical advantage. So this is nothing but mechanical advantage. F2 F1 is also called mechanical advantage. The factor minus the force increases. The multiplication factor is called mechanical advantage. Okay. So this is in detail in class 10. So you need not worry about it. Just the working arrangement. So we have 15 minutes. We can take up some numericals. So you have one question. Let's do the odd ones. Although you have even, but odd has some difficult questions, so I will take odd. So any questions now? So Hammer exerts a force of 1.5. And we have two nails A and B. Area of cross section. How much is area of cross section of nail 1? 2 millimeters. Area of cross section of 6 millimeters. So you have to find what is the pressure on nail A and pressure on nail B. And you have to find it in Pascal.
Should be converted force to
I can convert directly also. So what is millimeter square and meter square?
uh,
How much is 1 millimeter in meter?
1,000.
1000 or 1 by 1000?
Yeah, 100.
This will be meter square. So this is 1.5. Newton per meter square is nothing but Pascal. So this is 15 by so 7.5. So how much is this? 6 to the 12. This is what it means. what is P? H rho G. So P will directly get by this formula. What is H rho G? Find out how much is this. And then B will be F is equal to P into A.
So in board exams, they have not given the value of gravity and 10 considered 10. Used 9.
So you know the formula for pressure, right? Thrust upon area, F by A. So how much is centimeter into meter? So this is centimeter square, okay? What is this? 10 raised to minus 4. So this will be 10 raised to minus 2 meters. So how much is the answer? I'm getting 1.47. Are you getting this? 1.47 to 10 raised to 4. Roughly it will be 1.5 into 10 raised to 4. So which is right. And once you get this, how much is area? Area is 10 raised to minus 2. So this will be 2. So this is 147. This is correct. Hmm? So I am doing all odd questions. Right? So question 5.
So area we represent with capital A.
What else?
Small a would be acceleration.
Yes. Generally, capital A is area and unit of current.
Ampere.
Okay. So what is it now? So you have to calculate the height of water column which will exert on it so it's the same pressure as the 70 centimeter column of mercury. So let us say height of water column you are calling HW, density of water OW, G. This must be height of mercury, density of mercury and okay. So GG will get cancelled here. So height of water column will be equal to density of mercury upon density of water. So what is given here? So height of mercury is given as 70 centimeter. Density of mercury is 13.6 gram per centimeter cube. In water density, you have to remember it is 1 gram per centimeter cube. In kg, it is 1000 kg per meter cube. But when you convert that in gram, it becomes 1 gram per centimeter. Okay? And mercury in kg is 13.6 into 10 raised to 3. So it's 13.6 times density of water. How much is this? 6 sevens are 42. Oh. 7 3s are 21 plus 4 is 25. 952 centimeter or 9.52. So see, a 70 centimeter mercury column will be this much. Whatever pressure it generates at its base, to generate the same pressure, you need a water of 952 centimeter or probably 10 times higher, more than 10 times.
Because of its low density.
Yes, that's right. Yes. I switch off this AC. Okay, now it has a V part also. What is the V part? Will the height of the water column in part A change if the cross section of the water column is made wider? No, because no, it only depends on height, not area.
Density of gravity.
Yes,
And height is.
pressure only depends on X only. So area change that is a question. So, no change. No, since V is independent of area of cross section. Now this is an interesting question. Now you have a U-tube. Tube with a U shape, not U-tube channel. So what is that? What do you have in this? It contains mercury to the same level in both of its arms. Let us say the mercury level is 20. Then the initial level. Now what is happening is
Water is poured from a jar to give its liquid 1 hour.
let us say the water is poured here. So imagine the water is poured. So when when the water is poured, then what will happen? The water column will exert pressure here.
Yeah.
So let us say the water presses it till here. Okay. So by how much the mercury has, so mercury has gone down by, let us say x. Correct? So in the left arm, if the mercury column depresses by x,
It will rise by.
so it will be rise by x. Okay. So now, so at equilibrium. So what is the, this is x, this is x. What will be this then? X plus x. This will be 2x. Okay. So now consider these 2 points, point A and point B. Okay. So where is the mercury now? Mercury is not there. This full is mercury. This is totally mercury. And till here you have water. And water. Okay. Water height is given to you as 13.6 centimeters. Right? So at equilibrium, what will happen? So pressure at the same level is same. Right? So at equilibrium, PA is equal to PB. But PA is due to water. The pressure at B is due to mercury height. Okay? So this is HW, rho WG, and this will be H mercury. GD cancel. So how much is H mercury? 2x. And sorry, this is mercury. Right? And rho mercury is 13.6 gram per centimeter. Rho water is 1 gram per centimeter. H water is 13.6 centimeter. Right? So when you solve this 13.6, this you will get x is equal to, you get x is equal to 0.5 centimeter after solving this. This is good. So 13.6 centimeter gets cancelled, 13.6 gets cancelled. Gram per centimeter cube on both sides will get cancelled. What remains is 1 by 2. This is what it is. Okay, so the mercury rises by 0.5 centimeters in the other arm. Okay, let's see the next.